the Electrochemistry Lectures Part 5 under the Chemistry Lecture Series, and I am Dr. Anima Upadhyay. And in this lecture, we will discuss about the various types of electrodes, that is the half cells, and also the reference electrodes in detail. So in the Electrochemistry Part 5, let us first discuss the types of electrodes or the half cells. There are various types of electrodes such as amalgam electrode, metal-metal ion electrode, metal-metal salt ion electrode, gas electrode, oxidation reduction electrode, and ion selective electrode. And there are examples also given under those electrodes such as amalgam electrode is PbHg Pb2+, that is lead mercury in the lead ions. Metal-metal ion electrode is zinc in the zinc ions, copper electrode in the copper ions. So metal-metal ion electrode is quite similar to the amalgam electrode, except that there in the amalgam electrode we have used with the metal mercury also. The metal-metal salt ion electrode is one in which we have taken the metal with its sparingly soluble salt, and the two are taken in a solution of electrolyte having the same ions as the sparingly soluble salt. And the example is calomel electrode, silver-silver chloride electrode. The example for gas electrode is very common, that is the hydrogen electrode. Oxidation reduction electrode examples are ferrous-ferric couple, stannous-stannic couple with the platinum as the electrical contact and as the inert electrode. The ion selective electrode examples are glass electrode, calcium electrode, and the common example for the ion selective electrode is the glass electrode, which is used to determine the pH of any given solution. Now let us start with the reference electrodes. So what are reference electrodes? Let us first discuss that. The electrodes whose potential is known and it remains constant over a long period of time and wide range of temperature. Such electrodes are called reference electrodes. And the examples are standard hydrogen electrode, calomel electrode, silver-silver chloride electrode. So these are the reference electrodes. But we can further classify the reference electrodes into two types. Primary reference electrode, and the example is SHE, standard hydrogen electrode. That is the only example for the primary reference electrode. Secondary reference electrodes examples are calomel and silver-silver chloride electrode. So let us now see what are primary reference electrodes. The reference electrodes whose potential is arbitrarily fixed at 0 at all temperatures is called a primary reference electrode. And its example is standard hydrogen electrode whose potential is arbitrarily fixed at 0. But the electrodes whose potential is determined using the primary reference electrode are called secondary reference electrodes. And once their potential is determined, it remains constant over a long period of time and over a wide range of temperature. And the examples of secondary reference electrodes are calomel electrode and silver-silver chloride electrode. So now let us discuss the primary reference electrode in detail. As I have already told that the primary reference electrode is one whose potential is arbitrarily fixed at 0. And the example of it is standard hydrogen electrode. So how to construct SHE? It's very simple to construct. We have to take a platinum strip and we will enclose this platinum strip in a glass jacket which has an inlet for the hydrogen gas at the top. And this jacket is then inverted in a glass trough containing 1 molar hydrochloric acid. The hydrogen gas is bubbled through the inlet and the pressure is maintained at 1 atmosphere and the temperature is kept 298 kelvins. So this is how we can construct the standard hydrogen electrode. Now this electrode acts both as anode as well as cathode, and it is reversible with respect to the hydrogen ions. This we can see with the help of this reaction that it is reversible with respect to the hydrogen ions, and the electrode representation is written here with the platinum wire acting as the electrical contact. The figure for SHE gives a clear understanding of the construction of standard hydrogen electrode. Here, as I have told, we have taken a platinum wire whose lower portion is modified into the platinized sheet, and it is kept in a glass jacket which is inverted in a trough containing 1 molar hydrochloric acid. Here is the inlet for the hydrogen gas which is bubbled at the electrode, kept at 1 atmosphere pressure, and the temperature is maintained at 298 kelvins. So this is how the SHE is constructed. But there are certain limitations. It looks very simple construction, but actually it is not. It is very difficult to maintain the hydrogen ion concentration at 1 molar. Also, it is very difficult to maintain the flow of hydrogen gas strictly at 1 atmosphere. The impurities in the hydrogen gas may lead to the poisoning of the platinum electrode, which in turn can alter the value of the electrode potential of the hydrogen electrode. Also, this electrode cannot be used in the presence of oxidizing agents. Also, we can see from the figure itself that this is not at all a portable model. Therefore, we can say that it is very difficult to use it in the laboratories or in the common use. So, we need some other electrode which can replace the standard hydrogen electrode. Therefore, we will study the secondary reference electrodes which has taken the place of standard hydrogen electrode in the day-to-day practice. Thank you very much.